Okay, we're going to be doing an experiment that is related to the bun of a cheeseburger. Now, the bun in a cheeseburger is made by adding flour, a little bit of salt, to yeast. And the yeast eats the flour, and yeast is a one-cell creature. It eats the flour, and its waste product is carbon dioxide. And the carbon dioxide bubbles are what makes the bread rise and makes it nice and light. So we're not going to use the yeast to make bread today, but we're going to use the yeast to make soda. Okay, now when we make bread, we can add sugar to the flour, but we don't need to. The sugar and the yeast will eat the sugar or the flour to produce carbon dioxide. But when we're going to make our fizzy drinks, we're going to have the yeast eating sugar. Okay, so the yeast is going to munch on the sugar, and the waste products are going to be carbon dioxide, plus also alcohol. This is called fermentation, and this is the chemical reaction. So yeast plus sugar, which has carbon, hydrogen, oxygen in it, it's going to spit out alcohol and carbon dioxide. So this is a reaction that can be used to make bread. It can be used to make soda pop. It can also be used to make alcoholic drinks. It takes a little bit longer though. Any sort of sugar, such as sugar in grapes, if you add yeast to sugar in grapes, you will end up with some wine. So our problem today is we're going to look at how does the speed of this reaction, and we're going to measure the speed by how much gas, how much carbon dioxide is produced. How does this change over time? Does the reaction with the yeast and the sugar, does it get faster, slower, or stay the same? Okay, the students are making mint ginger soda. The way that they've done it, they've boiling 500 mils of water, and they've added fresh mint and ginger, and for the kids who really like minty flavors, they've added some dried mint. So the water's boiling now, and hopefully all the delicious minty ginger flavor is going in the water. Okay, the very hot ginger mint water is now being cooled down to about 37 degrees because that's the temperature that the yeast likes. If we add the yeast to the boiling water, it will die. Okay, so now the mint ginger liquid is being strained through this gauze into a beaker. So we're just going to get the nice, hopefully nicely flavored liquid. And all the other stuff will be left behind when we throw it out. Okay, so we've got the liquid that's been strained, and now we're adding a lot of sugar, 120 mils of sugar. Soda has a lot of sugar in it. Okay, so here we have Sam. He's mixing up the yeast in warm water, and soon this yeast is going to be added to the ginger mint liquid. Okay, we've added the sugar, now we're going to be adding the yeast. Half a packet of yeast was dissolved in some warm water. We're adding the yeast, and the yeast is going to be starting to munch on all that yummy sugar and produce carbon dioxide. Okay, we've now got the yeast sugar mixture in the conical flask with the balloon on top. We're going to be measuring the circumference of our balloon over the next few days to see, and it should be filling up with CO2, carbon dioxide, that the yeast is producing. And this shows us how fast the reaction is. Okay, the other part of the liquid, so some of the liquid is gone to, for our experiment, the other part of the liquid is going into a soda bottle. It's going to be sealed, and the yeast is going to eat the sugar, make the carbon dioxide, and make this nice and carbonated.